We're here with Peter at Townsend Foundry. We're going to check this out and ask him questions about how young people can get into these technical jobs. So this is going to be a great video, so stick with us.
But anyway, all of this product in here is stuff that we make all the time. Changes almost on a daily basis from what the guys might be running out in the field molding and doing that, along with all the grinding, cleaning, processing, and then eventually machining that goes on for the parts.
Okay, nice.
Parts in here that we've made for the Coast Guard, the Navy, minis, private yachts, houses, replacement parts for tractors and old engines and all of the other things that have gone by the wayside, which is part of the reason why we keep this skill and this trade going. Technically, right now, I think the American Foundry Society said there's close to 130,000 employees short in this industry alone.
Wow. Mostly silicon bronze, but aluminum too?
There's the bronzes are like 31 flavors of ice cream.
Oh, okay.
So each alloy, even in silicon bronze, there's 7 flavors of silicon bronze. There's multiple flavors of manganese bronze, multiple flavors of aluminum nickel bronze or aluminum bronze. Then there's tin bronzes, leaded tin bronzes, and so the list is enormous. And so each one has different characteristics in the way it's used, both in its strength or its wear and the way it's used. So, for instance, there's an impeller right here on the floor, which this is a tin bronze. And its housing that it goes in is actually a red brass. The two operating with the impeller spinning it at 3,400 RPMs. If the bearings get out of whack, the tin bronze sloughs off into a powder instead of galling in little round balls, which would freeze up the impeller. So those different alloys work well together in those kind of scenarios, as along with things like our shackles and turnbuckles that are really high strength material.
Okay. Do you do any cast iron?
I don't do any cast iron, mainly because the two processes don't lend themselves for each other. I've done plenty of cast steel, cast iron parts, but if you get cast iron or steel particulate in your sand, it contaminates the sand for doing the bronze work.
Oh.
Then it ends up leaving rust spots and various things throughout. So it's just a kind of the pouring and the cleanliness of the parts that you need to maintain.
Okay. What is it you made for Tally Ho?
Oh, everything from starting with all the bronze floors, hanging knees.
Is that what those are called? Those long...
The big bronze floors that went down.
Yeah,
were,
and the hanging knees were those...
Up on the shelf.
Okay.
Clamp and some of the deck beams in there. All the keel bolts, many of the clench rings, all the rudder fittings, bob stay, whisker stay, crans iron, stand plates, turnbuckles, all of the... Blame pin, gooseneck assembly, gaff saddle. I mean, that's just everything. Doublings up aloft, cleats, chocks, there were hawsers. You could just it's a boat, so there's a list.
So you're primary the metal fitting provider for Tally Ho's rebuild.
Yeah, I made a lot.
Okay, so what about Western Flyer? Did you do anything for Western Flyer?
Western Flyer, as a matter of fact, this is this seat, which is a helm seat that originated the base, and this part all started as a Wilmington Boat Works fishing fighting chair, but this is going into Western Flyer's laboratory down below. So the person writing on the computer and all that will have the best seat in the house.
Nice. Okay.
And for me, both of the boats I've known since a child. So I was lucky. Western Flyer was going up and down the central coast of California in the early 60s, and my parents owned a big boat that we cruised through Baja, only 2 years behind Western Flyer.
Wow. All right, so how? What's next? Let's talk about the process?
Yeah. So the things go on. A lot of the process that we use, this particular sand is an olivine volcanic sand, has no silica in it or any of the other properties that we don't want to breathe. So the beauty is it has two types of bentonite clay, and we use water to then activate the clay to bond it together. The beauty is it gets, because it's volcanic, you can pour 2,000-degree metal on it without fracturing the grain size, and that also allows each grain to have a microscopic coating of the clay on it, and that's what helps bond it together. But we get to use it over and over, and so what we do discard is usually done because people are walking in with pine needles or whatever, get on there, and we take that contaminant out. But we also recycle all our sand. As we process molds and they're made, they come down to the flooring area. So right now we're set up to run a row of silicon bronze parts. We have some aluminum pieces and then some aluminum nickel bronze pieces yet to pour this week, and we'll get those all done. So we typically use our crucibles go into the furnace.
Okay, so these don't have metal around them.
These are molds that are made inside of a flask that is designed to be removed from the mold so that you can make repetitive molds of the same thing over and over again, so that you can use the same flask in tooling. A lot of foundries may have permanent flasks, but they can only make one part in that flask, and have to pour it and break it out to use it again.
Yeah.
Where these are, and this is a old school technology. Modern machines today, you can get a molding machine that could make a mold almost twice the size of that and do 60 molds an hour. But you've got to be able to move the amount of sand, which is then very difficult.
Nice. And two parts, two halves go together?
All of these are cope and drag molds, but then the molds can have multiple cores inside that are going in every which direction, unrelated to the parting line of the flask.
Okay. And how hot does the thing?
Typically, silicon bronze is going to be pouring between 1950 and 2200 degrees. Aluminum bronze is going to be a little slightly higher, but each of the temperatures are depending on the parts you're pouring. So thicker parts are pulled at a lower temperature than thin parts, and that's all based on what we're molding and how we melt and do the production.
What's that a pile of over there?
That's a pile of silicon bronze slag that I'm collecting. I use these piles, and sometimes I can recycle the whole thing, but I also use them for mounting sculptures on. So I'm building a piece that someday I'll put a sculpture on, and that will patina out with a bunch of blue and green and really beautiful detail. We've done some of those like they were rocks underwater with oyster shells that we've cast mounted on them, so it looked like a piece of underwater material.
So you're going to fire this thing up here pretty soon. And how long will it take to heat?
About an hour and a half.
Okay.
Let's hit start.
Oh, cool.
And we can go upstairs. Is where all the patterns are made. Katie is up there working on various different patterns, and then from there we can look in the pattern shop and see the various different tooling.
Okay. So patterns are typically wood?
Well, they could be a combination of wood, metal. It depends on what the goal for production is. So if we're going to make hundreds of them, eventually there'll be match-plated tooling where the patterns are and engineering for pouring the metal is all done, versus say one-off parts where you're doing a single pattern that you're just using a couple of times. So depending on what the project is.
Okay.
So some of the projects we're currently working on and bidding this portholes right here that we're estimating and doing for that. These are for the Battleship Texas, which the Battleship Texas here was shown in Port Townsend Bay in 1919. So it's being restored as a museum ship in Galveston, Texas. And we've got parts over here. We've been working on engineering. This particular casting that we make, these castings are done as a complete circle, hollow part that we make, and then as machine and fit. But this is for the #1 paper machine at the paper mill, and these hold the main rolls inside. And we also have reproduced this part and other pieces on that machine Just even in the last month, we just did, or 2 months, we did 60 more table roll bearing housings for that same.
And that's designed to be the sacrificial bearing?
Yeah, even though we've had one set of these run for 10 years straight. Running that machine, and they're running the machine at 4 times the operating speed it was originally built for.
Whoa.
So it's doing a lot of work. Hey, do you mind if we come poke in at you just for a moment? Do you mind if we poke at you for a minute? Okay. So Katie's cleaning up some tooling that we have. This tooling makes the garbage cans, like one that's out front, and there's about 60 of them in town around here, but they're a Victorian style garbage can that we make, and they're cast in aluminum and then various different things. But I made this tooling, 35 years ago.
Time to update it.
Time to get it cleaned up and get a couple of things repaired.
So how do you calculate how much oversized you have to make the patterns?
Well, and the beauty for that is, right up here is a row of shrink rulers.
Okay.
So this ruler is 3/16 of an inch per foot longer. So this 24-inch rule is actually 24 3/8 long.
Okay.
So the real key is we have a selection of the shrink rulers all geared to the various alloys that we're going to be pouring in.
Because obviously they're going to shrink at a different rate.
Yep. And then you have to, sometimes it's all a matter of understanding your own process. Things that get over 24-inch may go up to like a 1/4 inch per foot or more, depending on the alloy. So longer parts shrink more in their lineal length than they do in their diameter.
And is there a factor for volume of metal too?
Well, the volume going in is all dealt with by the risers and the gating system.
Right.
So if you have a big volume at one end and then a narrow section and another big volume, that can be a problem in how you do the engineering, so you don't tear the part apart
when it's cooling.
When it's cooling and coming down.
Okay.
And that's kind of a phenomenon. Earlier you asked about iron or steel. All the old Singer sewing machines that had really curved spokes, that wasn't a design feature. That was a design to make the castings work. Because in the old days, the castings, if you had straight spokes and the outer ring shrinks more than the inner ring, it would crack the spokes.
Oh.
So by twisting them like that, when one
making
ring,
an S on them,
it makes them turn or twist slightly, but not compress or crack the spoke.
Oh, well, that's cool.
And so we use a lot of the old school type tooling.
Yep.
Using the lathe, table saw, all of the various things to get there. And sure, there's a lot of CNC wooden routers. All of that stuff are all possibilities in this realm. And computer printed molds, digitally printed molds, all of that stuff we've used in the past. So there's a lot of ways to tackle it. But sometimes the most efficient way is really getting right down to you're making the part right now versus having to sit and put it on a computer and then send it somewhere else, do all of that, and the type of machine. So that really is what helps keep the hand skills and the knowledge base that goes into the industry of viable.
So is there a particular wood that's better than other woods?
Oh, yeah, there used to be, really AFS pattern grade mahogany, which now you can't get out of Honduras anymore. So that, there's still a few sources. I have bought a lot from Edensaw over the years, and I still have pieces of that material that we do use for special project. We can go look in the pattern shop, but then a lot of the bigger companies, say Ford, they used to use a wood called but anywhere from bass or Geluton, which is soft, easy to carve. Those aren't tally hose floors. Those are floors from other projects.
But those are floors.
Yeah.
Those are floor patterns.
Yeah. So,
okay.
White floor patterns, pretty much all of those up there, those and the rest of those real big ones all went on a vessel called Fjord 3. It was built in Buenos Aires in 1946 by Herman Freyres Sr. And Herman Freyres Jr. was an apprentice draftsman for Olin Stevens. And so that particular boat was the first foreign hull to ever win the Newport to Bermuda race. And after it won the race, that's when Olin hired German Frères Jr. to become a draftsman for it.
Okay. And there's the other half of that pattern that she's working on?
Different parts of it.
Okay.
So there's
a different piece of it. Okay.
Bottom part of the can. And in here is close to 6,000 pieces of tinker toys, as I call them. But there's tooling that dates back in here all the way to reproduction parts from the original foundry from 1889.
So where was the original foundry?
The original foundry started in downtown Port Townsend, directly across the street from City Hall in Pope Marine, what is now the Pope Marine Park. So in 1889, they had 250 people a day working, and they cast all of the castings for the majority of the buildings downtown. They built 2 passenger steamliners and 2 tugs the same year, and built all the engines, everything, and all of that material came from the Irondale Mill, which they were partners in. So they were getting pig iron that was made here directly in Jefferson County and turned into product, which is either sitting in our downtown or it's part of San Francisco.
Wow. So is there one of those old patterns? Can you find one quickly?
Yeah, there's one hanging on the wall here. So this is an original casting from the Port Townsend Foundry that we reproduced about 60 more feet, and it's basically goes up like a widow's walk on the peak of the roof, and so that they added an addition to the house, and so we made all reproductions along with the spires. There's taller spires that go on each of the corners that go up.
Wow. Plaques?
Oh yeah, hundreds of plaques. There's City Hall plaque that's up here. We've done pretty much renaming plaques on all of the buildings downtown.
Wow.
And so you go back through. There's stuff we've done, benches, famous boats that have been in and out that we've done work on.
Yeah. Cool. So those pieces are designed to hold the ribs to the keel.
Yeah. And it allows for more room in the bilge versus having a wood floor, which takes a bigger timber across and there. So these are all either riveted or bolted through the frames and then to the keel.
Oarlocks.
Yeah.
Pretty cool.
Just a small box of oarlocks. These are all oarlocks of every different style and size. So there's literally hundreds of options.
So you'll do pretty much anything for anybody in the material you use, as long as you could do it, right?
Well, I haven't found anything I can't.
Okay.
So that's the fun. It's like almost anything that we could think about today, it's already been done at one point in time.
Yeah.
It's really hard to invent something new that's really new. I have catalogs from 1890s downstairs that are like Sears Roebucks from just a single company that has all vintage stuff exactly like what we're making today that they were selling. And we lost a lot of it.
Yeah.
A lot of the companies back in the day, some of their tooling was just taken out and thrown away when the company went out. And, and that's one of the things I've done is a lot of this collection is because I was going out and finding those little pockets where people had stored them and either buying them or getting them donated to us so we could keep them active. And that's, part of the fun. Some of the restoration projects, we're able to give them authentic reproductions off the original tooling to do the restoration. It's kind of like if you have a Corvette, you want a Corvette part, you don't want an imitation.
Yeah,
you want
exactly.
The real thing. So that's kind of fun, is being able to do that.
So your parts have gone all over the world, I take it?
Yeah, we've had parts in Tasmania, Australia, New Zealand, Japan, anywhere in Norway, France, Spain, you name it, anywhere they're racing. And a lot of the boats even that have been restored in the U.S. are now in Europe racing. That's one of the things that's kind of one of my pet peeves is the EU has restoration credits, tax credits for restoring antiquities.
Mm-hmm.
So a lot of the European people are buying classic yachts that were built in America and having them restored, and they get tax credits in Europe. Where our state is, let's destroy them. You know, DNR is, taking all the derelict vessels, but they're not really setting them aside and saying, look, this is an economic tool by somebody putting the money in to restore it. Instead, it's going in a dumpster, and that's a shame.
Well,
And that's part of having a culture that supports not only living wage jobs, but also a middle class society that actually used to have recreational vessels and could afford to keep them up. And so the demographics have really changed in how can you get a young family that wants to have a small sailboat, keep it up and go sailing? Well, they got to have a job that can pay.
yeah.
But also have to get society to understand that if I was to pay each one of them $100,000 a year, this product would be, $5,000 a piece when no one would buy them. So it's a real change right now of what we're going to see in the country. But I think it's really important that the youth get a chance to understand. And there's some studies out there I was just reading about the mental health of, Gen Z and the millennials. Well, they're being tied up in this computer world in a way that they don't physically do something with their hands that they can be proud of. And that's something I think that they really need to look at how they value a job, is coming back in and go, this is something I can do. I'm making something that will be passed on. And 20 years, I can go back and see it again, wherever it is in the world, and that's part of the fun is for us. And we can pretty much go to almost any port now and find stuff we've made over the years and see it still doing its job.
Yeah.
And that keeps the enthusiasm, all of the things that go along with operating a business or even being an employee. And that's one of the advantages. A lot of people think, I'm going to go out on my own and do all this stuff. They don't realize how much work it really becomes versus being an employee where you can really have some of the freedom but yet get paid well and be involved.
Okay.
So again, patterns in this area are ones from a collection from Rostan that started in 1902, I think, 1902, 1903, but ran until about 1993. So they had multiple products and pieces. They did everything from Pullman Railroad car parts. They did stuff for Ford, Mack fire trucks, Maxim fire trucks. They did a lot of different parts for both the sailboat industry, Luter's Yard, which was in Stamford, Connecticut, which have parts for a lot of different things. So, for instance, the Dawn Boat Building Company started in New York City, I think, in 1906. This is the original helm wheel pattern. We have some of their production patterns, as well as stuff like the dashboards for those vessels, which had the tachometer
And so
throttle.
somebody wanted an original with the name on it, they could come to you and
Get
that name.
Yep.
Which is pretty cool. So it'll be, in essence, be an original.
Essentially, it is an original, right off the original tooling. So.
Yeah. So we were talking about the sand.
Yeah. So essentially, the sand is an olivine sand. As I mentioned earlier, it's got two types of bentonite clay and water added. So running it through a muller, which is like kneading bread dough, basically turning the grains of sand and rolling the clay onto it, which then when the grains of sand are coated precisely with enough clay, then you add the water, you can then get it to bond together. So then the molds are made in what's called a cope and drag flask. The cope and drag flask has a bottom and a top that separate, so you can have your pattern removed to take it out, but you can then also open the flask up and take the flask off to make repetitive molds.
And you were going to show us that over here with these.
I'll show the part we talked about earlier, staircase tread. This is what's called a follower board. The follower board is built to be able to take the pattern, put it in place, and ram the drag up
So now as you ram the sand over it, scrape it off in this flask, it would be flush to the top, so you wouldn't see it at all anymore. But when you take and flip the mold over, then you remove the follower board.
And you only need the follower board in this case because you got a curve, right?
Right. If it's a flat parting plane, there would be either a match plate or a parting board in there. But then the other half is then pegged on, which then allows you to be able to then also put the gates, the risers, and feed the metal in the right direction for making the part.
Okay.
Oh, come on. And they're very precision the way they're built, so the patterns have got to fit exactly back together. Oh, come on.
And then that would be in there.
Yep.
Pack all the sand in again with powder. What was the powder made out of?
The dry parting is made from ground walnut or almond shells, and it's bleached. That's why it's white.
So you can see it in contrast to the sand.
There, when you get there. I do. You know, I'm going to end up messing with it too much. Perfect. There we go.
All right.
So that's the part. Then your cope and drag is going to be lifted off and allow that to separate. But also there's gates where the metal on the runner is going to come in and feed, and then risers on the opposite side to deal with the fact that this section and these sections are heavier, thicker sections than everything in between. Otherwise, there could be shrink voids or dents in the part when you're done.
And then you pull that out.
Leaving the negative of this shape in it, which then the metal will be poured into a sprue. The sprue is controlling the velocity and the speed in which the cavity is filled, and it flows through and then rises up the risers as it fills up.
Okay.
So for any one part, you may have 50% of the metal just in the runner, the gates, and the risers. So if a 25-pound part, you're going to pour roughly 50 pounds of metal in the mold.
And so you pull that out of the sand, and then you got to clean it up because inevitably some sand falls in there.
Yep. Hopefully the molder is seeing that if there's what's called tramp sand, sand that fell off of the mold or broke from any kind of pulling or action they did, they would clean that out of the mold prior to it being closed back up to keep it clean.
And if there's a little damage, sometimes you can fix it.
Yeah, depending on what the alloy is, say if these are in silicon bronze, a couple little pits, we could take a weld and fill all the voids, you'd never know. But the key is to really try to learn to be able to not have to do that.
Now, this is tapered, yeah?
Yep.
So it's tapered this way and tapered that way.
Yeah, it's got what is called draft. So draft angles are put on the pattern to allow the sand to release, and all of that is designed so these will be machined off so that they're perfectly parallel and all at the same height when all 32 of them are done.
And this piece here, is that part of it? The finished product?
This is a core print. So this is so I can take a piece of sand This is called a hot box core, but we place that into the mold in there, and it casts the hollow right through the part.
Oh, it's hollow through there. Yeah, okay.
Because of the design of the staircase, these are the baluster bolts, so the balusters get bolted directly through, holding the top and bottom of the
And
tray.
what's that made out of?
These are sand.
Okay, and
But
that'll hold up to the heat too.
This is what they call a hot box process, but it's resin bonded.
Okay,
course.
and so this is sticking out here in order to give you a shelf
A support for these
for that to sit on
Yep.
in the mold.
So all of these, they're all custom cores for different projects. They can be pretty extreme.
So tell us about what we just saw.
So you are in the grinding room, various different techniques for cutoff or grinding different parts that we cast, and all of the pieces have little different way to hold them or process them through. But generally in the grinding room, we're taking off all the gates, parting lines, any clinkers that might be left on the casting prior to going through into the machine shop.
Okay, thanks.
You betcha.
So we were talking earlier a little bit about somebody coming, new hire, typical day in the life of a new hire.
Yeah. Well, the new hire might start out doing anything from placing weights on the molds, starting to see how the sequence stuff goes. We have what are called ingot molds that any of the excess we have in our crucibles get dumped out. So a new beginner might just be shown how to make an ingot mold, which are very simple. They don't require all the detail or finesse for feeding, but they get a chance to start learning the sand. Learning the sand's the most important thing. Being able to learn how to process it, understand the different parts and how much moisture content may be required to be able to pull the what they call the draw, which is how deep maybe the cope or the drag is done. So all of those are a typical part. Then eventually they'll come in and we'll start laying out molds ready to pour. Once we pour, then they're probably going to get involved with the breakout, and that's where we actually dig the parts out of the sand, and then from there we process them, move them into the grinding room, doing some sandblast work, whatever it is, to clean the sand off so we can run them through the bandsaw and cut all the excess off. There's a lot of little steps to go through to pick up from the beginning.
Okay. And I noticed those shovels over there on the wall.
Yeah. The shovels are used to be a wall or each one of the shovels has been worn out by an individual. So I used to name them as they wore out their shovel. It's a badge of honor to have worn out a shovel in the learning curve. So
that's not a custom designed factory shovel. No. That's just wear.
It's taken off 8 to 10 inches of shovel worn away.
Wow. And how long did it take to do that?
Oh, it depends on the person, but you may run a shovel every couple of years worn out. So.
Wow. Okay. And then you were saying the bigger molds, like for example,
yeah,
over here, tally hose.
Some of the floors were cast in the big flask, which can hold as much as 6,000 pounds of sand. So the way that our shop is set up allows us to move all the smaller molding equipment out of the way and move the bigger molds where we're literally floor molding is what that is called, where you're doing the molds on the floor and then they go to the bridge crane to be manipulated and flipped over and all the process there.
What's the biggest thing you've ever poured?
Probably one of the more fun ones that we've done. Big molds that size was a memorial for a diesel mechanic in Morro Bay, California, and it's an F-150 Ford truck seat with all the diesel mechanics tools on it, as well as a Jimmy valve cover, specialty tools for reaming. But it's Naugahyde stitching, detail, sewing, rotten foam rubber, and it's all bronze. And it's all done in sand, but it looks like an investment casting.
Okay.
And the good part of that is, I mentioned about my shop teacher, I also reproduced a tap wrench that I made in junior high that teacher taught every student for 30 years how to make. So there's a reproduction of that tool on the bench because the fellow for the memorial also had the same high school teacher.
Wow.
So it's kind of fun to be able, and even my math and art teacher was involved in part of that, which it's kind of fun to take the time and stuff passed over the years and put it back together, and now it's on a waterfront memorial in Morro Bay, California.
So you started the business in
1981.
Yeah. Okay. And you several locations till you got. Yeah. How long you been here?
This building about 17 years now.
You think you'll ever outgrow this and have to move again?
Already have. As you can tell, we're pretty tight for space.
Yeah.
If we could double our facility, we would have, generally anywhere from 15 to 20 employees.
How many do you have now?
We're running about 7 to 9 of us, depending.
So you got enough business that you could double.
Yeah, and it's a matter of it's really, it comes down to an economics of what you're trying to do. So if all of a sudden, give you an idea, there's a couple of foundries right now. One is Ford Meter Box, building a 350,000 square foot plant. It's costing $350 million, and they're going to employ 128 people. That plant is going to be basically all automated.
And where's that at?
It's in the Midwest. So
Okay.
the concept of what we're doing, we're more of a short run, doing limited editions of things, or doing the same piece only 3 or 4 at a time, but we're very flexible and nimble. The bigger companies can't do that. They have to set up their tooling for high production runs.
Right.
But overall, the industry is spending millions. There's I think at least 7 or 8 plants in the 100 million range being
So you
built.
see foundry work guys coming back to the States?
It needs to. There's no way we're gonna be able to survive as a country or that without our own industrial complex. We can't outsource everything, and that's the sad part. Everybody says, "Well, what's a living wage?" And how do you define that compared to what we compete with? We compete with China, Taiwan, India, all of those places making cleats that we sell for $100, they sell for $12. It's not a fair playing field at all. No. And it's, I think we're doing our youth a disservice by making them believe that it is a fair playing field.
Yeah.
So we need to work on that. That's where, even when I started the company, I went to the city and asked for a place where I could set up the foundry, and it turned out that the city engineer at the time said, "No, we don't want you here. We don't allow smokestack industries." And I said, "Well, foundries these days aren't smokestack industries. EPA and the rest of it don't allow that, to be built. So why would you not want it? Because it's a legacy industry for this company." The original foundry started in 1883 and built all of the castings on all of the buildings downtown, all of the hardware for the Victorian houses. And you wouldn't want that to continue? No. He said no. But I said, "Well, give me a copy of your regulation book and I'll take it home and read it over the weekend." Well, I did. Turned out that there was a clause in one of those. So if you were a portable business, like a farrier or a blacksmith, somebody doing something on a trailer, you were exempt from needing a city business license. So I went back the next Monday and handed him a book back and said, "Read chapter so-and-so, and I'll be 2 blocks away from City Hall working in the street." And I put the foundry on a 8 by 22 foot flatbed trailer and worked for 4 years in the street.
Nice.
And so it's all about determination and following the rules, right? So rules and laws are made by us. Unfortunately, government's now using them against us.
Yeah.
And we need to change the philosophy and the motto to be able to say, I'm working within the rules that are created, bigger, higher, and even in where we are now. I worked there. I started at 327 Jackson Street, which was 2 blocks away from where the original foundry was. So it was kind of fun.
Are you in the city limits here? No. So this is county land?
Currently, Glen Cove is a what they call a Lambert. It's an area of other intense thing, but it wasn't included in the city's UGA because it's not part of the city, and that's a controversy that's going on right now. The city wants to turn us into and annex this property and take the tax revenue. And I said, I've spoken out publicly. What are you going to do to the craftsman community when you overtax them? And they want to change the zoning to allow box stores in. So if we're going to allow Home Depot, Walmart, Lowe's, we're going to put our local hardware out of business. We're going to put all the mom and pop shops out of business. Not to mention
the value of the properties.
And the property values will go through the roof, which means I cannot employ the young youth to be able to learn and teach them at that expense when the product would cost so much money. So I think it's a time for a lot of people to really speak out and start to change. And that goes back to the question earlier about getting kids involved. And getting kids involved means we got to get our schools to change. We got to get the schools actively bringing kids to industry in their own communities, because once you lose your youth from your community, the community will die.
Yeah.
So
typical work week for somebody is there much overtime?
We tend to try to, again, overtime costs more money, so
Yeah.
that's all based on the product. And if the product doesn't warrant spending overtime hours on it or isn't going to pay, we have to then minimize where that is. So some guys do get some overtime per week, but it's really, we're trying to watch and make sure we're not over extending ourselves.
It's more about if it's a critical,
Yeah,
somebody needs it immediately, they're willing to pay.
Or we're under contract. In other words, we have a deadline to meet. You got to
Okay.
get that done. Then we will dedicate the time.
So what is an entry-level person they could expect to earn a year?
Entry level, we usually start everybody at $18 an hour, and so it's 18 and up from there. And it all comes down to that teamwork ethic, the understanding, and how much they can comprehend the process and learn. And as that learns, then the pay scale can go up by the amount of production it's done.
Okay, so how long has your longest employee been here?
Oh, right now, probably 9 years or more. And then I've have others that are still working off-site, doing more computer work, soft skills stuff that have been with us about 12 years now.
Okay. So we're gonna go in the machine shop,
Yeah.
check it out. So this is the technical space, the highly technical space.
This is where you don't want to make a mistake, because all the work that's been done to get parts here, it's where you want to make sure you're very accurate.
Now, what are these?
These are handrail stanchions. So tubing, we'll go through them sequentially to make handrails to ground. So whether they're on a housetop or inside the boat,
Okay.
wherever they
And that's the mold he's doing over there.
similar, yeah.
Yeah.
For it's making this end, which is the back end that's
Oh,
for the end of the tubing.
Okay.
Where these are intermediates.
so pretty nice.
Yeah, once they get drilled, tapped, then they'll go back, and it depends on what the customer wants. Sometimes these will be get an oil rubbed finish, which is blackened and then oil rubbed, or they're going to get polished, high bright, and finished. And some people like just the satin smooth finish, so it really depends on what the
But on the elements, all go to a
Those go
patina.
a patina dark green.
Yeah.
This is 94% copper.
Yeah.
But as they go around, there's processes and parts for every little piece that has to be done. I can idea. There's a bigger one, so those fit 7/8 tubing. That fits 1.25 inch tubing, and we have them all the way up to, I think the largest one is 3-inch tubing.
Is there a particular part that you do most?
A lot of the things that we do. This one particular eye nut is one we've been making for over 40 years. And so I've even had a writer who came and wrote this article for a German magazine. So it was all done in German, but it was all about making just the sign through every single step, from that to polished to being and then the various different uses. So we make these both in Everdur silicon bronze, but we also make them in aluminum nickel bronze, so they're extremely high strength.
And what are those typically used for?
They're finishing out bolts so that somebody could either clip a line onto it. Halyards can be clipped to them. There's just numerous things.
Okay.
Reefing gear, where you have a dead end of a reefing line that goes up through the thing.
So that'll typically be drilled and
Tapped. And we do them in multiple sizes. And I think right now we have close to 30 different sizes and styles of eye nuts that go. Some of the biggest ones actually have a hex head that are about that big with a loop. You can put a big wrench on them to tighten them.
And you'll do nuts if people need nuts. You can make nuts for them.
These are all specialty alloys for various things. So if you're making aluminum nickel bronze keel bolts, you have to make aluminum nickel bronze nuts and washers to go with them, which then makes the high strength component.
Okay. Nice. So here's an example of.
Yeah, various different nuts we're doing.
All right. So this is typically where somebody would work their way up to being a machinist. And
Yeah, they'll start here with simple tasks like maybe hand reaming. Sometimes it might be just doing layout work. Where we start teaching them how to use the layout table, scribes, all that stuff to put the center punch marks where the machinist is actually going to do it. So they start learning ahead of time before they're even put on the machine how accurate they need to be to do the layout work.
okay. Yeah, you were mentioning earlier that a lot of machining instruction now does not do manual machining.
Yeah. So a lot of the bigger courses and stuff, they're all teaching CNC and digital stuff and CAD work, which is really a different forte. So my goal is really to teach the basic manual equipment first. Then you can go into that next step. Because if you have a good concept and grasp on how they're done manually, then doing the CNC stuff becomes even easier.
Yeah.
And you can start to understand what's more viable on a one-off. Can you do a one-off in a CNC as fast as they can do it here and do it manually? So there's a trade-off between that. And then given some of the tasks of the bigger CNC machines we'll use, as one is geared to the length. So the big one has a 50-inch travel, which means I can do 50-inch sections of T-track and all that without having to do it in a, say like with a small horizontal, one piece at a time.
Yeah.
Because I can put 10 pieces in that machine at once. Same with eventually the eye nuts. We'll have the machine build and mill fixtures. It holds the eye nut perfectly in a set of vices. So you can put 10 to 15, maybe 20 pieces in the machine, have it face them all, come back and drill them, tap them, which is manual stuff that will take the burden off of them.
Yeah.
So you'll have free range all the way here. You'll have to keep the outside again.
Right.
Yeah.
So do you want me just to give you, will it pick up my voice from over there?
Yeah,
So I'll be talking with them a little bit up and down, but
that's fine. No problem.
part of our protocol here is everybody under the bridge crane has to have hard hats. That's why you're outside of that level. Being able to handle it. We have two people that are involved with the actual up and down and the manipulating of the crucible. Everybody else is just tending the crane and keeping an eye that we're in line with our molds as we pour. All good. So what I'm doing now is removing all the slag and impurities that are created during the melt, or residual, what's called a fire scale copper gets. Excuse me right now. Excuse me, please. No talking. Want to be able to keep everything handled pretty well and pretty clean. Okay, we'll go towards the first mold. And going to come down. Hold there. Up. That's all right. Up. A little more. And up. There you go. And down. And I gotta scrape a little bit out. That's good. We'll go up. Okay. Yeah, back it all the way off. So now you'll be able to come up and have a closer look.
Metal goes in there, chunks, bits, scrap.
Ingots. Oh, yeah. So you're melting in the crucible go in.
Yeah.
It's also very important. All the metal, once you go from a cold start to a hot start, all the metal that goes in after the fact has to be preheated because it contains water.
Oh.
So you would have a steam explosion if it's not preheated. So there's all kinds of things that go on in that end of, but as you're feeding the furnace, because you could probably maybe put 50 or 60 pounds of material in there, but that crucible holds 310 pounds of metal. So as you feed that metal in, you preheat it, you get it in there. Then as we come along and pour, again, everything that we come out, the ingots are now made so they can be remelted, along with the cutoff, the gates, the risers, and the sprues will all get trimmed. And because this alloy can be melted repetitively without changing its properties, it's very easy to do.
Now you fired that up from a cold start about 2 hours ago?
An hour and a half.
And started melting. Now, if you did another pour,
I'd be ready in about 45 minutes.
and you got to worry about the metal going in there where it's hot?
Yeah, when we put another crucible in there, the crucible can take the temperature change from cold to heat, but all the metal going in needs to be preheated before it goes in, because most people don't realize There's probably anywhere from a tablespoon of water in each one of those. And I can get it out by just putting heat to one end, tip it up and heat the end, and it'll drip right out.
Wow.
Metal is much more porous than people think. It can absorb the water through it.
So what's that crucible made out of?
They're silicon carbide, so they are the same as the space shuttle shields for re-entry.
Oh,
so
okay.
They're just like the tiles. They're made the same way. They're fired and baked. They have a little more carbide in these for the strength to be able to hold the volume and weight of that material inside.
So how long do these have to cool before you can break them down?
They'll get broken out this afternoon.
And you'll pour these other ones today, too?
I'm going to probably pour the other ones tomorrow, just because I've got another group coming through. It's a daily entertainment center.
Okay. All right. Well, thanks for your time.
You betcha.
Okay.
It's always good.
Yep.
Send us lots of kids.
So that'll do it here from Port Townsend Foundry. And you guys know the routine. My channel needs some help. Feed the algorithm. Do the subscribe and like. And thanks again, Peter.
Yeah, you bet.